Hello and welcome to the new session. Here we are going to discuss the group multiplication table for point group C2v. I'm your instructor Saurabh Makhtibod. Thanks for watching this video. So let's proceed to the journey. Earlier we have studied that the properties of the group are defined by certain laws. The first point is that the product of any two elements in the group and the square of each element must be an element in the group. The second point says that one element in the group must commute with all other elements and leave them unchanged. It implies that at least one element should be of the type which when multiplied to the other there is no change in its magnitude. Any three members of the set must follow the associative law of multiplication, and every element must have a reciprocal which is also the member of the group. So if these four postulates or four conditions of group theory are satisfied, then that set under consideration would be defined as a group. Here we are going to impose these conditions to the case of water molecule which belongs to point group C2v, and it has the operation E C2 sigma v and sigma v dash, so two vertical planes and a two-pole rotational axis along with identity. And because it belongs to point group C2v, our set would be C2v is equal to, so identity C2 sigma v and sigma v dash. As we know that water is a very classical example of this kind. This angular molecule has a C2 axis and two planes as defined in this diagram. So now if we want to proceed for saying that this constitute a group or this makes a group, would apply the conditions of group theory. As defined earlier, product of two elements is a member of group itself. It means you take or the square of the element. It means if you take identity multiplied by identity, it is E. C2 into C2 is E, because rotation by 180 degree followed by rotation of 180 degree, that is rotation of 360 degree, that would again result in E. Sigma v done once is cancelled by sigma v done twice, it becomes identity, and so on. So the elements are the product of the elements is present in the group. Here we are trying to define that C2 followed by C2. If we are rotating by 180 degree, we get this, an inverted figure, followed by C2 again, we get the same thing. So C2 into C2 becomes identity. This is what we have tried to explain. But the interesting question is the product of C2 and sigma v, or sigma v and C2. If we start with water molecule, if we are looking at plus signs of hydrogens, it indicates that they are in the front side. So if I choose a plane first, sigma v, so the two atoms H2 would be replaced by H1, but they are again the frontier atoms, so plus sign is still there. And if I happen to rotate by 180 degree, now H1 is replaced by H2, but each atom has been inverted. So it's a back view of this. So the negative sign is there. So the product of sigma v and C2 can be realized by one step or in one step if I use this plane, that is sigma v dash plane. So using sigma v dash plane, I get the same thing. So I must say that sigma v followed by C2 is equal to sigma v dash. Similarly, if I proceed for C2 followed by sigma v, what I would do is I would rotate first so that atoms from the front side goes to back side and they are exchanged. One is exchanged by two. Oxygen remains of course in its own place, followed by a vertical plane sigma v. So it exchanges the atom H1 by H2, but the sign remains negative. This entire situation can be realized only by one operation, that is sigma v dash. So the front position, the frontier part goes to the back side, and we get the same thing. So conclusively we can say that sigma v C2 into sigma v is equal to sigma v dash. This helps a lot in understanding the postulates of group theory. The second, as we have discussed, that associative law of multiplication must hold. Take any three members, E C2 and E sigma v and C2, and put them in bracket. Solve the bracket components. Sigma v into identity is of course sigma, and C2 into sigma v is equal to sigma v dash. Just now we have seen. We have also seen that C2 into sigma v is sigma v dash. So this is also sigma v dash. Left hand side is right hand side. So the law holds true. The third point says that identity element must exist. So yes, it goes without saying that identity E is there in the set. And the fourth element says that a reciprocal element for each element must exist belonging to the same set. And I must say that each group each element is reciprocal to itself. Identity is reciprocal to itself, C2 is reciprocal to itself, C2 followed by C2 gives identity, and so on. All planes are reciprocal to themselves as a rule. So each element is reciprocal to itself. Now this helps in making group multiplication table. What we have to do is, you have to put elements into rows and columns just like this. So make a horizontal and a vertical line, write the point group under consideration, write the elements of row, write the elements of column. Now they need to be multiplied, so the first row and first column remains the same. This is first row and this is the first column, that would remain same. And then we are going to discuss about the rest of the elements. Understanding the fact that each element is reciprocal to itself. So E into E is E, C2 into C2 is E. So C2 is reciprocal of itself. Sigma V and sigma V dash are reciprocal of themselves. So what I should say that the diagonal element should fall to identity. Just look at this. The row, the column, the first row, the first column remains same, and see the diagonal elements one by one. I'm writing them as identity. Well then, we'll proceed to the remaining parts of the GMT group multiplication table. Now we have discussed earlier the C2 into sigma V or sigma V into sigma V dash, C2 into sigma V and sigma V into C2, that results in the answer of sigma V dash. So what we should do is, we write the elements in the row and column. First row, first column same, diagonal elements identity, and sig2 into sigma V becomes sigma V dash. So the next element without fail or without choice, it becomes sigma V, because as a rule there should be no repetition in a row and column. So once we do it, we are left with this choice. You can actually work out for C2 and sigma V dash also. So we have now filled these elements. Only one element in each row and column is left, as you can see. And as the rule of exclusion, we find that there is no element repeated. There should be no element repeated here. So in the last row, what is left is C2, and in last column, what is left is C2. Again, that makes a complete group multiplication table for C2v point group. And that's quite interesting and easy to construct. I hope this was an enjoyable experience to you. Thanks for watching. See you in the next video.